Hello, good morning, everyone. Welcome to UK Construction Week online webinar series. I'm Sema from UK Construction Week. Today, we will hear from Dr. Finian McCann on international sustainable construction. But before we start, I would like to run you some points regarding the platform that we use today. So you will be able to see live discussion box on the right bottom corner of your screen. And from that, you can chat to fellow attendees as well as send your questions to us. And at the end of the session, we will have time for the Q&As and Dr. McCann will answer your questions. We will also be recording this webinar and it will be available to watch on demand on the same platform and on our YouTube channel. So without further ado, I would like to introduce you to our speaker. Dr. Finian McCann is a chartered engineer with over a decade's experience researching various structural systems and materials, both in academic and industrial R&D context. He joined LSBU as a senior lecturer in 2015 after working as a subsea pipeline analysis in the offshore industry and a postdoctoral research associate at the Imperial College of London. Hello, Finian, welcome.
Thank you, Sena. How you doing?
So what I will do, I will leave the stage to you now and you can start your session. And at the end of the session, I will join you back and we will run the Q&A. Okay?
Yeah, just sharing my screen now. So is that showing up there?
Yes, all good. If you can put the full slide mode, that will be all okay.
Good stuff. Okay, no, so yeah, thank you very much for the introduction, Sema. So yeah, I'm Finian McCann. I'm a senior lecturer in structural engineering in the School of Built Environment and Architecture at London South Bank University. And more pertinently for today's presentation, I'm the civil engineering lead for the Sustainable Innovation Funding Scheme at the university. Okay, so I'm going to be talking about some of the work that we've done over the past year and also some other low carbon construction research that we're doing within the school. It's just as an overview, I'll give an introduction. I'll mention about some of the capabilities that we have, some of our facilities and research capacity. Then I'll show some case studies from the Sustainable Innovation Programme relating to sustainable construction and the built environment. As I said, show some of our other research within the school, and then looking ahead, what the scheme has in store later this year and next year as well. Okay, so just to give some information about the Sustainable Innovation Programme. It comprises two ERDF projects at the university, formerly known as Access to Innovation and Low Carbon London. Okay, so we've now merged these as a single scheme. There's combined funding of £3.8 million, and the idea is to connect local innovators within the Greater London Authority area with our academics and bring new low carbon products and services to market. So we provide these local SMEs with a lot of resources to design, build and test their low carbon innovations. Okay? So we develop these partnerships between ourselves and the local SMEs. So considering then what drives us, what motivates the program, it's all about creating these links between industry, innovators and academia. And there's a lot of benefits for all three different aspects of that. So we're passionate about sustainability. We get to work with cutting edge entrepreneurs. We remain up to date with the latest developments in technological innovation. So we can bring some of our students on to support these projects, and we often do. Sometimes I've got two MSc students now working alongside our research associates on some of the construction projects. Similarly, we can incorporate some of the projects into our teaching. And of course, these initial partnerships, if they're particularly successful, they could attract further funding. So we're trying to overall build a legacy at LSBU of being a low carbon university. And what's important to note is that the Sustainable Innovation Programme, and its commitment to sustainability doesn't exist in isolation. That actually aligns very, very closely with an overall commitment in the university towards sustainability. And to that point, our most recent group corporate strategy has a number of strategic pillars, and the foundations of each of these pillars is based on the UN Sustainable Development Goals. Okay, so everything that we're doing in the university has been programmed with these sustainable development goals in mind. So one aspect of the program is that we provide training and industry expertise. So that might be via technical workshops and boot camps, one-to-one business support, expert talks and networking events. And this is just some of the examples of the workshops that we've held over the past few years. But what I'm going to talk about in more focus today are our academic collaboration projects. Okay, so 2 of the schools at the university are involved in the scheme. That's us, BEA, School of Built Environment and Architecture, and also our colleagues in the School of Engineering. And as I said before, our research expertise is made available to local innovators, and they get access to our state-of-the-art equipment, our computational facilities, and also to research associates and research students where applicable. For SMEs that are brought in on the low carbon London scheme, there's also an opportunity for a 40% subsidy towards the cost of employing a full-time expert to strengthen in-house R&D. So we can recruit from outside as well on that particular scheme. So the team that we have at the moment is, so overall project management and coordination is Ellen and Bethan. And then within the School of Built Environment and Architecture, we're led by Isa, and then I'm the civil engineering lead, and my colleague, Dr. Roy Jin, is sustainable construction lead. And then our research associate within the school is Dr. Abdullah Kaban. I just have to take a moment here to acknowledge the tremendous effort and really, really top class work that Abdullah has been doing on these projects over the past year. And by the way, that's absolutely not to diminish the work done by our colleagues in engineering, so led by Sandra Dudley McAvoy with Stephen Perry as the department leads. And similarly, Rob and Matt have been doing excellent work on developing the SME partnerships in the school there. So we're very, very lucky to have the 3 guys there, Rob, Matt and Abdullah, doing excellent work on the day-to-day delivery of the various SME partnerships. So before I go on to talking about some of the case studies within the program, I just want to maybe just highlight some of the research facilities that we have within the university. So this slide looks a bit busy, but that's for a reason. Just want to highlight that we do a lot of things here at the university. We have a number of highly equipped, high-spec labs that I'll give a bit more information on in a few minutes. And what's particularly of note at the moment is that a couple of years back, we actually founded the Net Zero Building Centre with BISRIA, the Building Services Research and Information Association. So it's quite a productive collaboration with BISRIA to deliver on consultancy, but also research relating to moving towards a net zero built environment. Across our various different laboratories, we can determine mechanical, thermal, and acoustic properties. We can do chemical characterization, and we also have a number of high-powered microscopes. I'll give a bit more detail on as well. For maybe this is kind of more relating to our colleagues in the School of Engineering, but for device testing and device manufacture, we can do that in-house. So we can fabricate these devices and test them in-house. And then for, let's say, experimental specimens or product prototyping, we have 2 fully equipped workshops. And also of note is our digital architecture lab, which has a suite of 3D printers, additive manufacturing facilities, and also robotic manufacturing facilities. And I will talk a bit more about DAR Lab later on in the presentation. So this may be more the, let's say, experimental and practical aspects, but we also have a lot of expertise in numerical modeling, maybe in some aspects might call it computational modeling. So I've included the software packages more relating to structural mechanics, which I suppose is more in my background. So we've got Abacus, construction industry professionals, maybe you're more familiar with, Tekla, Robot, and Revit. But we have a lot of different academics who specialize in these computer software packages. In terms of life cycle assessments, we have access to SEMA Pro that our RA Abdullah has been using on some of the projects already. And of course, as a kind of fundamental part of any of the research initiatives that we're doing, we conduct quite thorough literature and technology reviews. So the actual, let's say, the actual activities that we would conduct for a particular SME partnership vary quite a lot, as I hope this slide displays. And it's all about liaising with the SME partner, seeing what they need and how we can support them best. So I'll give a kind of I suppose, a quick virtual tour of some of the lab facilities here. And I should point out that this is not exhaustive. There are other labs across the university, but today I'm going to focus a bit more on construction in the built environment. So we have a well-equipped structures lab, the strength and materials laboratory, with rigs, so universal testing machines up to 300 kilonewtons, and then we have a hydraulic loading jack that we have here on the right-hand side up to 500 kilonewtons. And I really need to pay tribute to our two technicians, Paul Elson and Graham Bird, who have a great output, and everything that we do in terms of experimentation is down to these two guys. So definitely need to give them my appreciation here. And as you can see, some of the previous testing we've done, let's say recycled glass bead sandwich panels, polylactic acid, so a starch-based polymer that's been 3D printed, and most recently we did some fiber reinforced polymer beams. So a lot of testing that we do covers a lot of different structural systems and materials. This is just a snapshot of some of the more, let's say, low carbon or sustainable solutions that we're involved with. We also, in the past few years, have moved into fire resistance testing. So we've got some ceramic heating pads that can heat up to 1200 degrees C. So this is some testing we did on high strength steel a couple of years back. And so that's the elevated temperature side of the testing. And on the right hand side here, we've installed and upgraded a fire resistance rig. So a propane based fire resistance rig. And we've recently upgraded our fume extractor system. So it's certified up to 1100 degrees C. So we're in the process of tuning this up to get it in line with BS 476, part 6 and 7 on flame propagation and surface spread. So we've done quite a few tests at elevated temperature, and we actually, one thing I haven't included here is that we recently also have a mini furnace. So for tensile tests, we can do that at elevated temperatures as well. And another one of the new toys, I suppose, that we've gotten over the past few years is a digital image correlation system from LaVision. Recently, so this is the polylactic acid tubes, the 3D printed tubes. And you can see here that we're able to extract an evolving strain field during the tests. And as we move into more specific, let's say, material processes and more let's say bespoke geometries and so on, we're going to need to be able to locate where stress concentrations are happening. So stress via strain concentrations. And the DIC system is exactly what we need for this. It's also very useful because it's non-intrusive. We don't need to apply any strain gauges. For elevated temperature testing, fire testing as well. We can also use that to measure strains evolving during an elevated temperature test. So yeah, we've made a kind of start on using this, and there's plenty more opportunities where we can apply the DIC system in the future. Another recent acquisition is our optical microscope, which has a lot of very, very neat features. This is so one of my colleagues, Dr. Ravi Shamas, he's doing a lot of research with basalt fiber, and we sent a sample to the manufacturers, to Keyence, to give us a demonstration. You can see here that we're talking about the order of 5 millimeters, and you can see the exquisite kind of detail shown up by the system here. So our push now is to move into micromechanical analysis, and having the microscope is invaluable for this purpose, as well as providing obviously the magnified views and the depth profiling. It also can do particle distribution counts, and I'll mention later on how we're trying to incorporate that into some of our research. So as I say, we've got a lot of state-of-the-art technology within the structures lab, and the same applies for many other departments across the university. and one of which is the Digital Architecture Laboratory. So it's headed by my colleague Federico Rossi from the Division of Architecture, specializing in digital design and automated fabrication. We've got a number of different 3D printers of various sizes. We can accommodate quite an array of materials, polymers, but also reinforced polymers. And we're now moving to upgrade the facilities that we can print in slightly tougher materials, maybe like polymer reinforced or carbon fiber reinforced polymers. We also have some large robotic arms, robotic manufacturing equipment. Federico has done a lot of great work over the past, I think it's the last 6 years. I think it was founded in 2015, Darlab, with some very high profile collaborations. And one thing that we're now moving towards is the use of 3D printing in structural load-bearing applications, which is the SCRAM project. I'll talk about that later in the presentation. So that's just a brief synopsis of some of the facilities that we have. As I say, it's not exhaustive. There's a lot of other great work being done by other colleagues across other divisions. But I thought this is kind of focusing on what we're doing in construction and the built environment. Okay, so I think what's important now is to highlight some of the success stories from the Sustainable Innovation Scheme. So over the past year, we've had quite a few collaborations already. Okay, so the way that the scheme is run, we take in SMEs in various cohorts. In 2021, we've had already, so from cohort 1 and cohort 2, what's that? Quick maths. 45 partnerships. And what I'm trying to get across in this slide here is that although I'm a civil engineer, structural engineer, my focus is on sustainable construction and the built environment. The scheme covers many, many, many different fields. So we're talking smart cycle hire over to solar power, to a carbon finance platform, seaweed-based packaging, smart electrical vehicle charging, and so on. And so this is, just want to say that the work that we've been doing, and Abdullah in particular has been doing, forms one part of a much bigger whole. So the cohort 3 applications, I mean, if there's anyone in the audience who is interested in applying, I will give more details about that at the end of the presentation. But our next cohort is going to be opening at the end of October. Okay? So hopefully this slide gets across just the plethora of different activities and fields that we cover as part of the scheme. So the first case study I'd like to highlight is with an SME called Pioneers. And their focus is on developing affordable and accessible low carbon and green construction for the Gambia. So the founder is a native of the Gambia, and he's interested in developing realistic ways of, let's say, democratizing sustainable construction, because more often than not, a lot of sustainable construction practices involve a lot of initial investment, and sometimes they're only really, let's say, useful for much larger developers, much larger stakeholders in construction. So we, as I must say, mainly Abdullah, he did a literature review of easily sourced construction materials within the Gambia, including clay bricks and straw bales. And so what we did is we ordered in a batch of straw bales, and we conducted some compression testing in our 500 kilonewton rig here, and just to see the structural capacity of this readily available material. Okay? So we've done an initial bit of testing as part of the program. For anybody who does end up ordering straw bales, they come in quite a large bale. So we've got quite a lot of material left over to do some additional testing. And the main kind of output from this particular project, as I say, you can see there that cohort 1, it ran from January to May, so it's quite focused. We do quite a burst of activity to deliver a specific output. And the specific output here is, in addition to a literature review of the useful materials, we also demonstrated the fact that these straw bales, although sourced from vegetative matter, can actually achieve quite useful load resistances. Okay, and especially, obvious I suppose, but especially when we plaster them as well. And then thinking then about ensuring and enhancing sustainability locally. Locally available materials such as coconut fibers or goat hair have been already shown to enhance the strength and environmental sustainability of the plaster. Okay, so this is an example of quite a focused application with already, even though it was across a relatively short time period, we've got quite an impactful outcome here. So the next SME then is Mugu, who are focusing on sustainable transport, and in this particular partnership with us on sustainable shipping. Okay, so they're South African based, and they wanted to explore how sustainable practices can be imbued into major shipping transport. Okay, so a literature review identified a number of strategies to reduce energy use and carbon footprints, carbon emissions at ports, such as using shore power systems. So the ships switch off their engines to reduce fuel output, connect them to shore-based systems, and then crucially to ensure that the shore-based systems are powered by renewable energy. We saw a number of examples of very effective waste management strategies in Cote d'Ivoire, in South Africa, and Dar es Salaam in Tanzania. An overall push to improving self-sufficiency of port buildings and to reduce energy consumption, and quite crucially to introduce water recovery systems to port areas. And a very, very useful output for the SME was a carbon emissions calculation tool. Okay, so we see that we have a blend here of literature review, technology review of practices, and then a useful output, this carbon emissions calculation tool developed for our SME partner. Next up is EcoFind, and this is a London-based construction entrepreneur who saw an opportunity to create an online platform to connect construction industry professionals, consumers, and so on with sustainable suppliers. Okay, so that could be sustainable building contractors, sustainable material suppliers, architects who employ sustainable practices, and engineers as well. And with the idea being that this could be like let's say an online, imagine something kind of like Amazon, but we're focusing on only promoting sustainable firms on the platform. So we conducted a market analysis of various different assessment methods and eco-audit tools. So the idea being that someone might apply to be part of the platform, we could assess them then, or the SME could assess them on their sustainable credentials. And then it allows the SME to make an informed choice about how best to assess whatever products and services that we might want to, or they might want to host on the platform. There's analysis of competitor online construction marketplaces to discern best practices. And then we also conducted surveys across various sectors in the construction industry, so various different stakeholders in the construction industry to determine opportunities for products and services. And so this is a nice project with, again, a very useful outcome and some real industrial engagement. So we're now linking our SME partner with various different stakeholders across the industry and providing, let's say, a position that they can leverage and exploit then later on in their development. Quite related to this then, to EcoFind, was a totally separate SME, but on a kind of a similar idea about developing so there's a smart design formula. And the idea here was to create a similar online platform, like an online marketplace, but to connect tenants or homeowners. So rather than, let's say, a contractor or let's say a consulting engineer, that's kind of the market that EcoFind are probably more pushing towards. Smart design formula was the idea is to connect homeowners and tenants with who might want to do some home improvements to enhance the sustainability and reduce the carbon footprint of their dwellings. So we explored the establishment of a user-friendly platform to connect residents and homeowners with local sustainable home improvement suppliers. We did a market review of various different home improvement suppliers available on the high street. We provided some advice on how best to conduct life cycle assessments. So again, so that they can develop a rigorous system to assess any potential suppliers that might be hosted on the platform, and also then a competitor analysis of existing platforms. So again, it's on a similar vein to EcoFind, but definitely more focusing on a tenant or a homeowner. And so again, we're kind of democratizing access to low carbon and net zero innovations through initiatives like this. Okay, so the next one now is back to kind of the first one I showed there, 5 years, was quite practical, doing some experiments in the lab, and MIMA is definitely let's say even more kind of practical based again. So an SME based in London, they have an idea to develop and to deliver high performance solar panels for the Sudanese market. Okay? So despite the enormous potential for solar power in Sudan, there's in fact limited research done on solar panel performance in these conditions. So this is where we enlisted our environmental chamber. So we've got quite a well-established and well-used environmental chamber measuring, and I hope I'm not doing any colleagues disservice here, I believe it's 3 by 3 by 6, so kind of about the size of a container. So you can do quite a lot with the environmental chamber, where we regulated the temperature and the humidity conditions. And you can see here from the photo, the guys here are testing the potential, the voltage performance, voltage behavior across the solar panel. And this was then subjected to various conditions in terms of temperature, heating, but also moisture and dust. So trying to simulate desert conditions within parts of Sudan. So these full seasonal variations. So we simulated 4 different seasons, various different months throughout the year, and these, using the environmental chamber, we managed to simulate these in just a space of 2 to 3 weeks. The influences of panel temperature, dust cover, and water cooling on the voltage behavior was captured. And what would the real important outcome and the deliverable for our SME partner here was to identify where are the most optimal locations within the country, within Sudan, to maximize performance of these photovoltaic panels. Okay, so you can see here that under certain conditions, especially with cooling, the temperature has quite a big effect on the performance of the panels. So this mixture of temperature, but also water cooling, seem to have quite a noticeable effect. And then the last case study I'm just going to show is actually, so the previous case studies I showed there, they're all from the first cohort. So they're cohort 1, which was the January to May run. And this is just one that we're currently working on, hybrid energy solutions. Okay, so there's a similar initiative with NEMA. And the idea is to provide a proof of concept of a hybrid wind and solar energy system in sub-Saharan Africa. And the benefit here is that during blackouts, it can run continuously 24 hours because it's utilizing solar and wind, and therefore it'll reduce the occurrence of blackouts in let's say more disadvantaged areas. Some of the aspects that I'm going to be looking at in this particular project, we're assessing the influences of building heights and the solar panel to wind turbine ratio. So how do we boost the power and what blend of the two systems within this hybrid approach will give us the best power output. This is going to involve a review of system installation, architecture, specifications, and also project costs. So as I say, this is ongoing work, and that's kind of a snapshot, I'd say, of some of the work that we've been doing. I think I listed 6 SMEs there, and as I say, we actually covered the whole scheme so far this year has covered 45 SMEs. So these are the ones that kind of lend, or let's say, more focused on sustainable construction and the net zero built environment. But I also now want to move on to some of the kind of similar initiatives that have been conducted within the school, the Built Environment and Architecture, BEA. So I mentioned earlier on there that DAR lab, our digital architecture lab, is involved in 3D printing, additive manufacturing, and so on. And a project that we recently won, myself and a few other colleagues within the school won from the UK Manufacturing Symbiosis Network Plus, we're titled SCRAM, Sustainable Construction Through Robotic Additive Manufacturing. And the idea here is that we are aiming to develop a process of taking recycled polymers and then repurposing them, processing them so that they can be used in a 3D printer, and then used then to then we incorporate robotic additive manufacturing to produce structural scale components. Okay, so we've already started this. We've actually done a bit of materials testing. So far, we focused on virgin PLA, polylactic acid, and a collaboration with Mitsubishi Chemical. We're then going to start bringing in more of a blend between virgin and recycled polymer material, and we're going to examine various different polymers. We've already done some feasibility studies on the volume of recycled plastics that could actually be used by the construction industry, and we've got a conference paper on this coming out. But the potential savings in carbon are actually quite significant. We're not going to end up replacing, there's not enough plastic to replace all of the concrete and steel that we're using at the moment, but there's actually enough that would make quite a dent on the amount of carbon that's emitted each year by the construction industry. So that's some of the initial feasibility studies that we've done. We've already started determining some mechanical properties of this, the virgin PLA, and then we'll bring in the recycled and quite usefully the reinforced polymers. And so we'll examine the incorporation of various different reinforcing materials. Then what's important then is we need to move then towards the definition of a digital workflow for the entire process. Okay, so we have a component that needs to be designed. We design that using computational analysis through topological optimization. We then need to create a slicing algorithm, need to define, let's say, graded infills, various different optimizing processes for the component, define a tool path that then the robotic arm can then follow to create a large-scale structural component. Okay, so we want to kind of move, more often than not, when we think about 3D printing, especially with plastics, it's probably in the scale of, let's say, tools or maybe handheld components, or maybe slightly larger. But we now want to expand this towards structural scale components. And then, of course, the proof of the pudding, I suppose, would be some structural prototyping where we're demonstrating the feasibility of this technology. So I'd say that this was awarded in June of this year. Southern Federico have done a bit of testing previously last year on elliptical hollow section 3D printed tubes, and quite kind of the nice output here was first of all that when you scale the material properties in the right way, they are as kind of pound for pound, they're as effective as steel components, and also that the absolute value, the actual performance, the actual resistance of some of these components. And just to give you, this dimension here is 100 millimeters. So this is quite a small and slender component, but it was still capable of resisting around 20 to 30 tons of load. Okay, sorry, 20 to 30 kilonewtons, 2 to 3 tons of load. So a small component made out of a polylactic acid, which is a starch-based polymer. It uses vegetative matter in its derivation. Can actually realistically, I'm not going to say compete with steel, but it can provide replacement for more kind of light gauge components. And then when we move into slightly more stronger materials, and especially when we reinforce them, we'll see a lot of benefits being returned. So this is what the SCRAM project is focusing on. Another initiative that I've been working on over the past few years, together with my collaborators at Vitromite UK. So they're a manufacturer based in Norfolk. It's these recycled glass bead sandwich panels. So we have a matrix of recycled glass beads coated in a polymer resin that's then sandwiched between two fiberglass sheets. And obviously, there's an implication for circularity and carbon savings by using recycled glass, and they're quite versatile. You can use them as this is an example structure that's been built with the panels. They can use as floor panels, wall panels, and this was later then capped with roof panels, all made from this recycled glass bead material. You can see here that there's air voids trapped within the matrix, which then enhances the thermal and acoustic performance. And we've done some acoustical testing at the university. And kind of one of the most recent outputs, so a paper earlier this year, that the structural performance when we're using them as floor panels matches the performance of lightweight concrete or light gauge steel floor systems. So we're not going to be, let's say, replacing concrete and steel in a high-rise structure, but for let's say for lighter use structures or temporary structures or residential structures, these can realistically be an alternative. Okay, so this is then, we've done a lot of experimentation with the panels. So we've done compression tests, bending tests, tensile tests. My colleague Haider Aygun from the Building Services division within our school has done acoustical testing. And you can see here again our fire resistance rig where we test out the panels in there. So that's a collaboration with myself, Carlos Gonzalo, and Dr. Alex Puri. And so we've been doing a lot of research on these panels over the past few years, together with our partners. And so the past while has focused quite a lot on experimentation. We're now moving a bit more into the numerical aspects. We've produced design guidance in the past. But now we want to get down to the nitty gritty. We want to get down to the micromechanical level. And this is some work I've been doing over the past month. So just in case anyone thinks that academics, kick back on the sun loungers for the summer, not at all. We're busy working away on research. So we want to then couple the capabilities of our microscopes, particularly in returning particle size distributions. So that's a really useful feature of our microscope. And then using that statistical data, we can then feed that into an algorithm that can just create a stochastic, a random bead matrix. Okay, so varying the sizes and the spacings based on the statistical distributions that were measured by the microscope. And then this is just some kind of trial runs that I've done lately. We can then see the very, very local stress distributions within the matrix. And the idea here is that what we want to do is we want to manifest the macro scale behavior that we're seeing from the tests here by using this micromechanical analysis. And so far, it's actually going quite well. Now, just to kind of give an indication on the legend here, the red stresses here are 25 MPa. So we can see locally the glass, and that's around the crushing strength of glass, is around 20 to 25 MPa. But if we then, let's say, get an effective strength across the entire cross section, so that's incorporating the polymer, the glass, and importantly the air voids, we actually end up with a very similar result of around 2 to 2.5 MPa for the, if you want to call it like the merged material. Okay, so already with some of the initial calibration studies, we're actually seeing a manifestation of the macro scale behavior based on this micro scale analysis. So very, very happy to get a good start on this. And once we have our microscope up and running at full steam, we'll be able to achieve quite a lot here. So just to give a highlight of some other low carbon construction research within the school, my colleague Dr. Rabi Shamas has done a lot of work on basalt reinforcement. So that includes basalt reinforcing bars, and also then the inclusion of chopped basalt fibers into reinforced concrete. So Rabi's done quite a lot of work on that over the past few years and is continuing to do so. So my colleague as well, Professor Maria Mavrilidou, she's our soil mechanics expert, and she's done a lot of work on cement replacement, both for concrete applications, but also for soil improvement. So this is just I'm not really doing it justice with the amount of research that Maria is doing, but this is a very, very, very brief synopsis of some of the topics that she's covering, like alkali activated cements, reactive magnesia cements, biocementation, so using plants and microorganisms to actually to precipitate minerals, and then the use of industrial waste as aggregates. So a lot of research been done by Maria over the past number of years. And then finally, I say finally, there's a lot of other research going on in the school lending towards sustainable construction. I guess I'm kind of focusing a bit more on the civil and structural engineers here. But Dr. Rabi Shamas and Dr. Vereen Libacha have been doing work on the performance of recycled concrete aggregates. So taking old concrete, crushing it down, and reusing it as an aggregate, which has been proven in numerous other studies to significantly reduce the impact, the carbon footprint of concrete. And so the guys here and some students, they've been doing material characterization and beam testing over the past while. Okay, so hopefully that provides a bit of a snapshot of some of the commitment that the school and also the Sustainable Innovation Group has put into sustainable construction. And I guess I'll kind of move on to closing up the presentation by looking ahead. So hopefully there might be members of the audience who are interested in applying to the scheme and working with us. And the next cohort of applications is going to open in late October this year, with the applications running to mid-December. Okay, so the projects themselves would more than likely kick off around, I would say, early in the new year is when this next cohort will actually get up and running in terms of the project work. It's open to SMEs with a registered or operational address within the M25 that are focused on developing low carbon innovations. And applications can be made by an online form available at the project website, which I'll give you all a look at in a second. Now, at the moment, the application system isn't live. It will be live in late October, but expressions of interest can be made in the meantime. And just as a final bit of information here on eligibility criteria. So you need to have, so it's an ERDF, European Regional Development Fund backed scheme. So again, prices in euros here. The business has received less than 200 grand state aid in the last 3 years. Be an SME with less than 250 employees, turnover less than 50 million euro. Crucially, of course, be a company developing a low carbon product, process, or service. And then in terms of the geographic restrictions, be a business registered in the GLA area, Greater London area, or you can be registered elsewhere in the UK with an operational address within Greater London. Okay? And sole traders are more than welcome to apply as well. Okay. So before I jump over and just give you a quick look at the project website, just here's some emails. If you have any questions about sustainable innovation, or if you'd like to get in contact with some of the SMEs that I've shown there, please send an email to the team. You can also send an email to our project manager, Alan South. And if there's anything else, maybe about research or opportunities at the university, feel free to send me an email as well. And just before I wrap up, I'll just give a quick look at our project website. This is the Sustainable Innovation website. There's an application button up here. And we also then have a number of case studies for you to browse through and to peruse, should you wish. So yeah, that's all for me. So thank you very, very much.
Thank you very much, Finian. That was absolutely fascinating, and we've got so many questions here already. So I'm going to start one already on the list, if that's okay. What type of businesses are you looking for in the next round of applications to the program?
I suppose that question might have been answered here.
Okay.
But honestly, yeah, in terms of the actual innovation that's been developed, it's wide open. As long as the idea is to develop a low carbon product, process, and service. There are, of course, the eligibility criteria here. But I mean, a lot of startups and innovators.
Yeah. And I believe LSBU will share the details via email after the webinar anyway. So the audience will receive the details via email also. Okay, I'm just jumping on the questions now. There are a number of them, so I'm going to start from the top, if that's okay. Has any research been carried out in the use of palm leaves or bamboo as local construction materials?
Bamboo, yes. We actually have done a bit of work on bamboo. Palm leaves was actually mentioned as part of the literature review. Palm leaves came up in the Pioneers project. But one of our MSc students, literally 2 weeks ago, was testing bamboo reinforced sandwich panels. So that's a research that Dr. Vereen Limbacha has been doing, and also Jennifer Hardy in our school as well. She's done a lot of work on bamboo structures. So yeah, no, absolutely. That's as we've seen from many other parts of the world, bamboo is just a naturally used and very, very strong and resilient material. So it makes sense that we research it as well.
Perfect. So there's the next question here. Are there any strength, degradation, or other properties of recycled glass polymers with time?
So glass is inert, and the polymer, it depends on which polymer is used. The exact polymer that is used is commercially sensitive, so I can't go too much into it. But essentially, the fiberglass sheets on the outside provide the environmental resistance. So one thing that we would like to start doing is some accelerated aging testing of the panels, just to prove their long-term durability. But I suppose if you go kind of a material by material level, the fiberglass sheets, the glass beads themselves, and the different the polymer that's there, they do have the potential to be quite durable.
Mm-hmm. There is, on that topic, there's one more question from Ramzin. What is the FR class achieved for recycled glass polymer?
Sorry, Sammy, could you repeat that?
Of course. What is the FR class achieved for recycled glass polymer? We can ask maybe Ramzin to elaborate that question.
Yeah, could maybe just clarify on the FR?
Yeah. Okay, Ramzin, if you are with us still, if you can elaborate your question more detailed, we will get into that. So there's another question here, actually, same from Ramzin. Do you have set up for CWCT as well? I believe he asked this question on the slide, digital image correlation. Does it ring a bell? Do you have set up for CWCT as well? Or we can ask Ramzin to elaborate that one as well.
I have to elaborate the CWCT as well.
Yeah, if that's okay, Ramzin, if you can be more clear on the questions, we will get back to your questions. Julia Stevens, she made a comment on here. Many thanks, Finian. There are a lot of synergies between this and what we are doing at Constructionarium. She will be in contact with you, which is great. Just to remind everyone, our audience as well, the session has been recorded and you can re-watch it. And it will be available on this platform under the on-demand tab, as well as our YouTube channel. Okay, Ramsey came back to us saying fire resistance classification.
Right.
Does it? Okay,
yeah, that makes more sense.
Okay,
Sorry.
Thank you, Ramsey.
Yeah. So the issue in terms of like fire resistance is the use of the amount of polymer that's being included within the recycled Class B panels, which is why the manufacturers are actually researching dropping as much as possible. And this is where the micromechanical analysis is going to become quite useful. Can we optimize the amount of polymer that's included that would then reduce, the fume release issue. So that's one thing that we're looking at. At the moment, the idea is that the fiberglass outer sheets provide a lot of the fire resistance time. It's just that then if there was ingress into the core, try and get the if you got so the fiberglass sheets provide a lot of resistance, but then if it ingresses into the core, then that's something that we need to look at. But by optimizing the polymer content, we can reduce that issue.
Okay. I believe we've got one more question from Janet. Is it for startup limited company which is dormant?
We can include sole traders as well. So as I say, in terms of the eligibility, anything less than 250 employees, and we include sole traders as well.
Okay, that's brilliant. Ramsey again commenting, testing for wind pressure, moisture, and impact testing for cladding material.
So yeah, we can do. We have actually tested cladding panels in the past. In terms of wind pressure, that's something that we can set up in the rigs, and we have kind of artificially applied moisture in the MEMA project. Yeah, so when we're testing the solar panels here, we can test moisture. What were the other two aspects mentioned there, Sarah?
Wind pressure, moisture, and impact testing for cladding.
Yeah, and we actually have impact transducers that we ordered in a couple of years back. So yeah, we can do drop load testing as well.
Mohammed, question regarding the contact email addresses. The team from LSBU will email you back with all the details and also contact details and eligibility, etc. after the webinar ends. There's one question here. What are the opportunities beyond the program? So after you have been through a cohort of sustainable innovation.
So we also, people have SMEs have the opportunity to reapply for another cohort, and there's a lot of different funding avenues that we as academics go down. So like the one that makes the most sense would be that anything that's being developed as part of sustainable innovation probably has quite a high TRL, technological readiness level, which would make it quite suitable for an Innovate UK grant. So we do, it is something that the university does quite a lot of, joint bids between the university and an innovation partner. And we do a lot of applications for Innovate UK. So that's just, off the top of my head, that's one that would work, fit quite nicely. There's also the opportunity to do KTPs, knowledge transfer programs, partnerships. Again, either through Innovate UK or through other opportunities as well. So there's if you do have a particular kind of idea in mind, definitely would recommend sending us an email, because there's quite a lot of different routes and they're useful for specific applications. If there's something that you developed as part of sustainable innovation, and then you wanted to kind of progress that a little bit further with a focused project, then applying for another cohort would make sense. If you then wanted to expand this into a much bigger research program, then maybe like a 2 or 3 year project funded by Innovate UK might make more sense.
Okay, that's brilliant. I'm just checking the questions again. There's one more here. Are there any emerging low carbon technologies, sustainable practices within the construction that you're excited about?
Yeah, I think the emergence of alternative materials is very, very promising. And there's a massive, well, there's been a lot of, let's say, a lot of publicity about off-site construction, prefabricated construction, and so on, which is coming more and more and more into the construction industry. Probably hasn't been exposed or exploited as much as it could. So this kind of let's say this marriage between new materials and new construction practices, and this is something that we're looking at as part of the SCRAM project. That we're going to take, let's say, polymer materials, recycled polymers, maybe with some reinforcements, and then see if robotic additive manufacturing can make a difference there. So I think this is where, one of the trends that I suppose we're seeing is that we're moving from construction as a construction process and maybe more towards a manufacturing process, a manufacturing paradigm, where there's a lot of things churned out in factories, brought on site, assembled. Now, people have been saying this for a long time, of course. I keep saying in 10 years' time, in 10 years' time, in 10 years' time, this is where we'll be. But I think the drive for net zero is going to require some kind of imagination. And I think the new materials and the new processes are kind of the most exciting development in that line.
Perfect. I've got more questions coming in. Thomas asked, is there a view on likely design lives for these innovative materials compared to more conventional construction materials?
Yeah, so this is something we'd like to confirm with more accelerated aging testing. But if I go back to the FRP beams, oh, it is. Oh yeah, that's okay. Yeah. Okay. So this is a firm out in Essex. They specialized in fiber reinforced polymer beams, and particularly for marine applications. So if you compare this to regular carbon steel, and if you compare it to, say, concrete that's been reinforced with regular carbon steel, then the design life in such a kind of a saline environment is going to be quite short because of corrosion and so on. So in particular, applications, something like a fiber reinforced polymer beam just makes a lot more sense. It's also more lightweight, so it requires less energy during transport and assembly. But then in terms of kind of a design life, materials like this that use kind of more inert materials, they will naturally have pluses for durable lifespans.
Okay, I think we are almost the end. I'm going to have one more question and we're going to wrap it up if that's okay.
Sure.
Chris is asking, has any work been done utilizing hemp?
Hemp? I don't think so. No, not that I can think of. So the idea of exploring hempcrete came up in one of the literature reviews. I'm pretty sure again it was for the Pioneers project. No, actually, sorry, no, it wasn't. It was for a different project on the scheme that we did 2 years ago. The entrepreneur himself was very, very fond of the idea of exploring hempcrete, but us ourselves, we haven't done any specific testing on it. But more than happy to, if there's an opportunity to get
Okay, one more quick cheeky question came in very quickly. I want to ask. Janet is asking, startup company without any money, can they help for our funding?
Startup company without any money.
Yeah.
I'm not exact, but I believe so. This is definitely one to send us an email about, and
okay.
we can clarify that.
Okay.
I'm pretty sure that it's more of a it's more of an upper limit in terms of turnover and so on, rather than a lower one. But I'd recommend sending the team an email, and we can clarify that.
Okay, sounds good. Well, that was a fascinating webinar, Finian. Thank you so much.
Well,
We've got, I'm sure, more questions will come. And just to remind all our audience, the session has been recorded and it will be available for you to revisit on the platform on demand in our YouTube channel. And LSBU's teams will be in contact with you all as well. They will send you the deadlines, details, all the contact information of all the fascinating projects that's been done so far, and how you can kind of apply and give you all the details. So thank you, LSBU, for organizing the webinar, running the webinar, and Finian, you were excellent. Thank you very much for joining.
Thank you. Thank you for hosting us. We really appreciate it. And thank you, everybody, for listening.
Thank you very much. Just to let everyone know, we will be running more webinars in the upcoming weeks, and you're all more than welcome to join us at UK Construction Week in October 5th to the 7th at the NEC Birmingham.